Binomial Experiments. We're going to start a couple of lessons that deal with binomials, and we're going to start in this video, our objective, to determine whether a probability experiment is a binomial experiment. So before we can do anything, and binomials are different than those that are not binomials, before we can treat it as a binomial, we first must make sure whether it is a binomial or not. So this is kind of the, is this or is this not a binomial? If it is, we'll move forward, future videos. If it's not, we're gonna shift it someplace else. Okay, what is a binomial probability distribution? It is a discrete probability distribution that describes probabilities for experiments in which there are two, the prefix bi tells us that, mutually exclusive, also called disjoint, outcomes. A couple of notes regarding binomials. The two outcomes are generally referred to as success and failure. And experiments in which only two outcomes are possible, they're called binomial experiments. However, you need to meet certain criteria for that to be the case, and that criteria is right down here. Let's take a look. Get myself straightened out. There we go. Criteria for a binomial probability experiment. Okay, an experiment is a binomial experiment if it meets these four criteria. Number one, the experiment is performed a fixed number of times. Each repetition is called a trial. Number two, the trials are independent. The outcome of one trial does not affect the outcomes of other trials. Number three, for each trial, there are two mutually exclusive, also called disjoint, outcomes. One of them we'll call success and one of them we'll call failure. We want to note that success doesn't necessarily mean something positive. You may be focused on soccer penalty kicks that are missed, in which case you're focused on what we would call a failure, but as far as you're concerned, if the soccer player misses the penalty kick, for you that's a success because that's what your focus is. And if the soccer player makes the penalty kick, for you that would be a failure, for example. So success just doesn't necessarily mean it's a positive outcome. It's the outcome you're focused on. And number four, the probability of success is the same. It's a constant for each trial of the experiment. All right, a little bit of notation we're going to make use of. Let's just recap that briefly. N is the number of independent trials of the experiment. Let me come back up a little bit here. As we know, it will be a fixed number, okay? P is the probability of success for each trial. Okay, we're talking about a binomial, so it's either going to be a success or a failure. So we can write down the probability of success plus the probability of failure is going to equal 1. Those are all the choices. You're either going to succeed or you're going to fail. And so since that covers everything, this probability plus this probability is equal to 1. Which means if P is the probability of success, we can subtract P from both sides, and 1 minus P is the probability of failure. Okay, you might want to write, you could also write it this way, probability of success plus probability of failure is equal to 1. Maybe that'll help you a bit more. Capital X is the number of successes in n independent trials of the experiment. So the possible values of X, this stands for the possible values of the number of successes of capital X will be between 0 and the number of trials inclusive. An example or two is going to help because that's a fair amount of math language. And let's see if we can't make that a bit simpler with an example. Okay, allow me to do a quick switcheroo. Get hopefully reasonably straight on the screen, and here we go. Remember what we're doing here. We are simply determining, as this first line says under example 1, we are simply determining, is it or is it not a binomial experiment? Am I straight? I don't feel like I am, but I could be wrong. Is it or is it not a binomial experiment? We're not going to do anything with it until upcoming videos. Is it or is it not binomial? For those that are binomials, identify the number of trials, the probability of success, the probability of failure, and the possible values of the random variable x. Okay, first one. We have an experiment in which a basketball player who historically makes 80% of her free throws is asked to shoot 3 free throws. And we're going to record the number of free throws that she makes. Okay? Is this a binomial? Letter A. Okay, first criteria. Fixed number of times. Okay, that's our criteria. The experiment is performed a fixed number of times. Well, it's going to be performed 3 times. So the answer is yes. Right? 3 times. Fixed number of times. We don't ask her to shoot basketballs forever. We're going to stop at 3. Letter B. Independent. Excuse me, not letter B. I should say, well, I'm sorry. Let me do a little bit of racing. I apologize. It was criteria 1. I'm sorry about that. I'm glad I caught myself. Criteria 1 this is example 1A. And my first criteria, is this experiment performed a fixed number of times? The answer is yes, it's performed 3 times. Our second criteria, are these trials independent? Okay, are they independent? Does the outcome of her first shot affect the outcome of her second shot? Or does second shot affect third shot? No. There's no effect. I mean, I guess you could say a little bit of fatigue maybe, but we're going to say that she doesn't have any fatigue shooting 3 free throws. So yes, the outcome of the first free throw does not affect the outcome of the second free throw. Number 3. Okay. Are there 2 mutually exclusive outcomes? One we're going to call a success and one a failure. Yes. Make or miss. I only have 2. She can only make it or miss it. And they are mutually exclusive. There's no such thing as a make-miss or a miss-make. Okay? So yes, they are. I only have 2 and they are mutually exclusive. And our fourth criteria is the probability of success constant. The probability of success for each trial constant. Okay, constant. And the answer is yes. The probability of making it is 80%. So therefore the probability, that's constant. She makes 80% of her free throws. The probability of success is constant. Okay, let's answer these questions. Number of trials, we did that. Okay, 3 trials. Let's come to here. There are 3 trials. Probability of success is 0.8. I'll tell you what, let me do you one better so you can have your notes. I'll put a probability of success, and I'll use an abbreviation with an S, and my S's always look like 5, so I put little ticks on them. Is 0.8. What's the probability of failure? Well, that's 1 minus the probability of success. So the probability of failure is 0.2. This has to total to 1 because in a binomial, it's either going to be a success, in this case a make, or it's going to be a failure, in this case a miss. There's no other choice. That's 100% of everything. And finally, possible values of the random variable x. Okay. X, capital X, is equal to number of free throws made. Okay, so we're going to be, our lowercase x is going to be 0, 1, 2, or 3. Those are the possible values of the random variable x. She's going to make she's going to make 0, 1, 2, or 3 of those. So we determined that this was a binomial experiment because it met these 4 criteria, and we came up with number of trials, probability of success, probability of failure, and the possible values of the random variable x. Number 2, letter B. Getting confused with my letters and my numbers. Getting old, I guess. Letter B. An experiment in which 3 cards are drawn from a deck without replacement and the number of aces are recorded. Okay, first, fixed number of trials. Fixed, I should have said trials up here. I think I wrote down times. Fixed number of trials. Boy, having a tough time, looks like. This should say trials. I bet you all caught that and you're thinking, what is he talking about? Fixed number of trials. Yes, we're drawing 3 cards. Right? Drawing 3. Okay, letter B, criteria number 2. Are these trials independent? Are they independent? Okay. Does the outcome of one trial, in order to be independent, the outcome of one trial cannot affect the outcome of another trial? Well, I'm going to kind of combine this with number 4, which speaks to the probability of success. Okay, because it kind of falls in both categories in this case. Let me come back up to here. We are not replacing. Okay, we're not replacing, which means when you take a card and don't put it back, you've affected the next one. Okay, if you took a card and it's an ace and you don't replace it, you've changed the chances of getting another ace because you took an ace out of the deck. So that kind of work, that does speak to both of these. The probability of success changes. Okay? If you take an ace out, the probability of getting another ace, well, there are only 3 left. So you've changed the probability. Okay? The independence is similar here. Okay? You take a card out, you're affecting the outcome because there are fewer cards in the deck. You've changed what's taking place. So those 2 things are both big no's. We can ignore the mutually exclusive and we can say not a binomial, binomial experiment. Okay, it has to meet all 4 criteria. And by and large, if you're not going to replace something, you're changing the outcome very, very quickly. So there you have it. Let's remind ourselves, a binomial, we can use this sheet. We're talking about criteria. Is this or is this not binomial? Are there a fixed number of trials? Is every trial independent? Are there 2 mutually exclusive or disjoint outcomes? And is the probability of success this constant? You need to meet all 4 of those criteria to be a binomial. We'll start working with binomials in the next video.